Hi everyone, welcome to JavaTechie. Today we'll start a new series of Kubernetes. Like always, I will explain all the concept of Kubernetes from very basics. So let's begin with an introduction journey to Kubernetes. Agenda of this tutorial to brief you about what is Kubernetes, why do we need Kubernetes, and at high level we'll understand the feature of Kubernetes. Okay, alright. So let's get started. So let's begin with what is Kubernetes. Kubernetes is an open source container orchestration engine or container management tool. It automates deploying, scaling and managing containerized application. So if you observe the term carefully, container management tool, this term itself self-explanatory that Kubernetes will manage your containers at runtime. That's the reason it is also called as a container management tool. So I will tell you more about this container management tool in a moment. But before that, if you guys don't know what is containerized application or how to run a Java application in a container like Docker, then I would strongly recommend you to check out my Docker playlist. If you'll go to my YouTube channel, you can find a separate playlist called Docker. So you must need to watch this particular playlist before you jump into the Kubernetes. Okay. Kubernetes is also called as K8S because if you observe there is 8 character between K and S. And this Kubernetes was initially designed by Google Lab and it's now maintained by the Cloud Native Computing Foundation. Kubernetes is completely open source and it is written by Go language. So far we understand the basic history of Kubernetes and also we understand that Kubernetes is also called as a container management tool. So let me split this word to explain you in a better way. Container management tool. Okay, as you know, Docker is a container where you can run any application like Java, Node.js or Angular. Kubernetes will manage those applications which is running on your Docker container. When I say Kubernetes manages the application, it means Kubernetes will take care of deploying, scaling, scheduling and load balancing your application which is running on your Docker container. That's why this is called as container management tool or container orchestration engine because it manages and orchestrates container activity. This is where the container activity deploying, scheduling, scaling and load balancing your container based on the user load or based on your requirement. On behalf of you, Kubernetes will take care of this activity if you are running your application on container platform. So I hope you understand what is Kubernetes and why Kubernetes is also called as a container management tool. Now let's discuss an use case to understand why Kubernetes came into picture. So let's say I have two microservices, microservice 1 and microservice 2, and each microservices connect to their own database and both the microservices can communicate with each other using Kafka messaging queue. Okay. And now I want to run the entire application in a container like Docker. So what I need to do? First I need to Dockerize the microservice 1. Since this is my Spring Boot application, I need to create the Docker image of microservice 1 which is nothing called Dockerizing the microservice 1. Then I will deploy that microservice 1 in a container 1. Similar way, I need to Dockerize the microservice 2. Then I can run it in a container 2. And then I can take the pool of Kafka image from Docker registry or Docker hub and then I can run that Kafka instance in container 3. Similar way, I can take the pool of database image from Docker Hub and I can run this particular database instance in container 4. Okay. So this is how I can run or deploy my application to multiple containers the way we deployed in container 1, 2, 3 and 4. And here I can able to manage these containers as well because the count is very less here, isn't it? I am just using the 4 container. So I can manage the container like I can scale it whenever it need. I can schedule the deployment anytime whenever I want, or I can manage the load balancing. Everything what Kubernetes does for us, I can manage by myself because there is very less count of containers. Okay. But practically in real time, we are not playing with only 4 containers. We are using n number of containers for each application. If you consider any e-commerce application like Walmart, Flipkart or Amazon, they used multiple containers to ensure availability so there will be no application downtime, scalability to achieve the high performance. They must need to use multiple containers and it's not that much easy to manage containers manually. When I say manages means it will cover deploying, scheduling, scaling, load balancing, batch execution, rollback, monitoring, automatic bin packing, self-healing, all those things you need to take care manually. It's difficult to manage those many things manually, isn't it? That's where Kubernetes came into picture. You just write your code and push your image to container like Docker. then next everything Kubernetes will take care. That's awesome, isn't it? Like Kubernetes, there is few more container management tool available in market like Docker Compose, Apache Mesos Marathon. But Kubernetes is widely used in industry because it supports a lot of features like deploying the container, scheduling, scale up and scale down the container based on the user load, load balancing the container, rollback and rollout, monitoring the container, self-healing and automatic bin packing, etc. So I will explain all the features of Kubernetes in my upcoming tutorial. Apart from that, components of Kubernetes is well managed to ensure availability, scalability. That's why it's more popular as container orchestration engine among other tools. So in my next tutorial, we'll discuss components of Kubernetes. I will explain each components and its purpose of using in details. So these are the Kubernetes components: pod, node, cluster, replication controller and replica set, service, deployment, secrets, ConfigMap and etcd. Okay. So these are the Kubernetes components. I will explain each and every components. Let's begin with what is pod and node. Okay. In Kubernetes, we are not interact with container directly. The containers are wrapped into a functional unit that is called pods. Okay, and a pod can have a single container or it can have multiple container inside it, and each pod associated to a single IP address. That's how one pod can talk to another pod. And there is another virtual or physical machine where all pods wrapped into it, that is called node. Okay, so a node can have a single pod or it can have a multiple pods. Okay, now again multiple node wrapped into another physical unit, that is called cluster. So cluster either can have a single node or it can have multiple node. Okay, Kubernetes cluster are comprised of one master node and a number of worker nodes. These nodes can either be a physical computers or virtual machines depending on the cluster you created. Okay, now if you will try to understand from backward direction, we have a cluster, and inside the cluster we can have a single node or multiple nodes, and inside each node you can have a single pod or multiple pods, and inside a pod either you can have a single containers or multiple containers. Okay, so far at high level we understand what is pod, node and cluster, right? Now let's move into the next component, that is replica set. As you understand in previous slide that pods are running inside a node and each pod associated to a unique IP address. Now let's assume I have pulled database image and running that containers inside a pod. So let me name this pod as a database pod. Okay. As you know, each application always need to interact with database. But let's assume due to some memory or CPU problem, my database pod got crashed. Now how my application will handle all the traffic which is coming to these database pods which is not running? It may leads huge cost impact to my application, isn't it? So how to overcome this? Or how can I ensure that there is no application downtime? That's where replica set component came into picture, which will act as a replica or backup of your pod. For example, let's say I created 3 replica for my database pod. When any of your pod will crash, immediately Kubernetes will bring up the new pod from replica set and it will assign a new IP to that specific pod. You can create as many replica you want for a specific pod, and these things you need to specify at the time of creating the deployment object. I will talk about deployment object in a moment. So far we understand how this replica set works, right? If there is any pods goes down or some pod got crashed, immediately it will replace a new pod with a new IP address. Now let's move into the next component, that is service. So as you know, inside a node we can have multiple pods. Let's name this pod as a front-end pod where my Angular or client application is running, and another pod I will name it as a backend pod where my server-side code or Spring Boot application is running. And each pod assigned to an unique IP address. That's how they can connect to each other, right? Front-end pod can talk to the backend pod using the IP address. Also we understand if any pod die, then immediately replica set will bring up a new pod with new IP address. Okay, but what if this will keep going? I mean, due to some problem pods are keep dying and replacing with new pod with new IP address. In such kind of situation, my front end pod can connect to the backend pod because IP is keep changing, right? That's where service came into the picture. Now each pod will associate to one service or multiple pods can group together into a single service with label and selector. I will talk about this label and selector in my future session with an example. But for now, let's assume one pod associated to one service. Okay, where service will provide an static IP and DNS name. So going forward, each pod can talk to each other using DNS name rather than using the IP address. Okay. Let's say if backend pod's down, then under the hood, replica set will replace a new backend pod. It won't impact to the frontend pod because frontend pod still can able to connect to the backend pod with service DNS name because the life cycle of pods and service completely different. That's pretty cool, isn't it? Apart from managing the service discovery role, service also play the role of load balancer where traffic coming to your pods will be handled by service. Then service will redirect to available pods based on your loads. There are different service type used in Kubernetes like cluster IP, node pod and load balancer. These services differ by how you expose your pods internally or externally and how you handle the traffic. So I am not going to deep dive types of service now. We'll understand this in our coming session with an example. So I hope you understand enough information about service component. Now let's move into the next component, which is deployment. Deployments are Kubernetes objects that are used for managing pods. You can scale your application by increasing the number of running pods, or you can update the running application using deployment object. Also, you can configure number of pods, CPU, memory, everything through this particular deployment object. If you can observe below command, kubectl, create deployment, fast deployment, then Docker image, then port number, and we are specifying the replicas. Okay. Here we are telling to the Kubernetes that create a deployment object with name fast deployment, then pull image from local Docker repository or from Docker Hub, and then create a active pod with 4 replica pods, which you can consider as just a blueprint or backup of your actual pods. So instead of using this command to create deployment object, you can also use the YML file, which is nothing deployment.yml file, and you can create a deployment object with that. Okay. So in an example, when we will do a Spring Boot CRUD application, I will show you how you can create the deployment object using both command prompt as well as the YML file approach. Okay. Now let's move into the next component, which is secrets and config map. First of all, both secrets and ConfigMap used to store sensitive information of your application like password, secrets key or API key. Let's say I deployed one Spring Boot CRUD application to Kubernetes. Usually we do configure our database properties in Spring Boot application.properties file or application.yml file, right? Which is not secure. If any changes done in configuration, again you need to rebuild your Docker image, then you need to deploy it to the container, which is kind of rework for a developer, isn't it? Why not we'll separately manage this sensitive info outside of our application. Since we are using containerization platform, why not we'll directly use Kubernetes component to store my sensitive information. That's why to manage secrets and configuration of your application, Kubernetes provided two components, secrets and config map. These two are placed outside of pods. So if you observe, secret and config map present outside of the pods so that inside a node if there is multiple pod, they can point to the same secret and config map. They can reuse the secrets which they configured in the secret object. Okay. And the main purpose of using two different components to store sensitive information is that where in secret you can add sensitive information with encrypted format. However, in config map it will store as a plain text. Let's say for example you are configuring your data source properties, then only the password you can configure inside the secret and rest other URL driver class name and username you can configure inside the config map object. Now let's move into the next component, which is etcd. Kubernetes used etcd as a key value database. It stores the configuration of the Kubernetes cluster inside the etcd. Also it stores all the secrets and config map data inside etcd database, and the max limit is 1 MB to store secrets. Okay. So this is what all about etcd, config map and secrets. We'll discuss more about these three components when we'll deploy a CRUD application to Kubernetes. So I believe you understand good amount of context about components of Kubernetes. So what all components we'll learn today, in my coming session we'll demonstrate all with real-time example. Okay. So in my next tutorial we'll understand architecture of Kubernetes. previous tutorial, we understand components of Kubernetes, right? Let me give you some basic overview about pod, node and cluster, what we discussed in our last tutorial. As you know, in Kubernetes, we are not interact with containers directly. The containers are wrapped into a functional unit that is called pod. So a pod can have either a single container or it can have multiple containers. And each pod associated to a unique IP address. That's how one pod can talk to another pod. And there is another virtual or physical machine where all pod wrapped into it, that is called node. Okay, so a node either can have a single pod or it can have a multiple pods. Now again, multiple nodes wrapped into another physical unit, that is called cluster. So in a cluster, it can have either a single node or it can have multiple node. So this is what we understand about pod, node and cluster in our previous tutorial, right? Now in this tutorial, let's discuss basic architecture of Kubernetes. Before we start learning the architecture of Kubernetes, you must have basic knowledge about its components. If anyone is not familiar with Kubernetes components, then I would strongly suggest you to check out my previous video. Otherwise, it's difficult for you to understand the workflow. Okay, so let's get started. Before we directly jump into Kubernetes architecture, let's go through a simple example. In an organization, there is a manager who usually manages multiple projects and each project assigned with multiple developers, right? Now what is the role of manager here? Manager will monitor all the projects whether it is running smoothly or not. Also, manager will check whether all developers are working or not. Apart from that, if any developer left from the project, immediately manager will assign a new resource to that specific project. Similarly, if any project getting closed or completed, then all the resource from that existing project manager will tag them to a new project, right? This is what a manager does. Now let's link this term to Kubernetes component. So this organization, you can consider it as a cluster, and as you know, inside a cluster we can have multiple nodes. So you can consider manager as a master node and projects as a worker node. And also we know inside a node we can have single or multiple pods, right? So you can consider developers as a pod inside a worker node. Okay, since master node act as a manager, what you will do, master node will monitor all the nodes whether it's running smoothly or not. It will monitor their health, resources and memories. Master node will check whether all the pods are working or not. Similarly, if any pods are down inside a node, immediately he will assign a new pod with a new IP address. In case if any nodes are down, then immediately he'll tag all the pods from the existing node to a new node. So this is what all master node does. In Kubernetes, there should be a minimum single cluster, and inside a cluster, there should be at least one master node and one worker node. Hope this concept is clear for you. This is what the basic architecture of Kubernetes. Now let's go deeper to understand more about components of master node and worker node, and also we'll understand how master node will communicate with worker node. Okay, let's begin with master node and its components. As you understand, master node manages the cluster and it basically monitors node and pod inside a cluster. Master node has four components: API server, scheduler, controller manager and etcd database. We'll discuss each component one by one. Let's begin with API server. So this API server will act as a cluster gateway. Each request coming to your cluster will first served by API server. Basically, API server expose few API to access all the operation going on inside a cluster. You can access API server either using command line tool, which is kubectl, or you can use Kubernetes user interface. Let's say I want to check health of my pods or nodes. Then simply I can run the kubectl command, kubectl get nodes or kubectl get pods. Once I run this command, request will not go directly to your worker node. First, the request will be intercepted by API server. Then API server will check all the worker node and pod running inside it. Then it will give you the status of your pods and nodes. Okay. So this is what the API server does in master node. It will just act as a cluster gateway, or it will just act as a entry point of your master node. Okay. Now the next component is scheduler. Scheduler usually plays a critical role in a master node. It usually schedules pods across multiple nodes. For example, let's say you have two worker nodes and you want to scale up your application. So for that, definitely you have to increase pod count, right? That's where the scheduler helps you. What scheduler does, it will go and check memory and CPU uses of each worker node, and based on availability it will schedule pods to that specific node. And if you observe, the first worker node utilized 90% of its CPU, and the second worker node already utilized 30% of its CPU. Then the scheduler will schedule the pod inside the worker node 2, not inside worker node 1, because this worker node 1 already used 90% of its CPU, and this worker node 2 is free here, right? It only used 30%. That's how scheduler take the decision on which node new pod should be scheduled. Now you might have a question: how does the scheduler know all the information about node and pod, right? As you know, Kubernetes internally uses an etcd key value pair distributed database. It stores all the information about your cluster and its states, and from etcd API server fetch all the cluster info, and he share those information to the scheduler. That's how the scheduler works. Now the next component is controller manager, which is another crucial component. So what controller manager does is it detects cluster state change like pod crashing or node crashing. When a pod crashed, then immediately Kubernetes bring up a new pod from replica set, and then controller manager will talk to the scheduler to schedule a new pod to a available nodes. Okay, and again controller manager manages to the multiple controllers like node controller, replication controller, endpoints controller, service account and token controller, where node controller monitor and respond all nodes activity, replication controller monitor health of pod. If any pod goes down, then immediately he will take the action. Endpoints controller is responsible for manage all service and their communication. Similarly, service account and token controller is responsible for maintaining account, API access and namespace. So these are four components of master node. Usually they keep monitoring the health of your cluster. We'll practically understand this when we deploy our first application to Kubernetes. Okay. Now let's understand components of worker node. Okay. As you already know, a worker node is nothing, it's just a virtual or physical machine, and inside a worker node we can have multiple pod, and each pod can have either single containers or multiple containers inside it, right? Worker node has three components: kubelet, kubeproxy and container runtime. Let's discuss one by one. Kubelet is an agent running on each node, and kubelet communicate with master node using API server. The kubelet works in terms of pod spec. A pod spec is a YAML or JSON object that describes all about your pods. So what kubelet does, it takes a set of pod spec that are provided through various mechanisms, and it ensures that the containers described inside those pod spec are running healthy. Okay, and this kubelet only manage the containers which was created by Kubernetes only. Now the next component is kubeproxy. Kubeproxy is a network agent which runs on each node, and it is responsible for maintaining network configuration and rules. These rules allow network communication to your pods from inside or outside of your cluster. Basically, it helps you to expose your services to the outside of your world. Kubeproxy also communicate with master node using API server. Now the next component is container runtime. A container runtime, also known as a container engine, and it helps to run containers which is running inside a pod. As you know, in Kubernetes we can directly access the containers, so all the containers are wrapped inside a functional unit called pods. That's where our application was running, right? And these containers engine provide runtime support to all the containers which are running inside a pods. So these are the basic component of Kubernetes worker node. Now we understand what is master node, and also you understand what is worker node, right? And master node can communicate with the worker node with the help of API server. So this kubelet and kubeproxy from worker node will communicate to the API server, and they can share the information about all the worker nodes. Okay, so this is what the basic architecture of Kubernetes. So I hope you understand good amount of knowledge about Kubernetes components and its architecture. If you have any doubts, then please feel free to ask in comment section. So in my next tutorial, I will guide you how to do environment setup for Kubernetes. Going forward, I will use my Mac machine to demonstrate all example of Kubernetes. So if you guys are learning this series using a Windows machine, then please do install a VirtualBox with Linux or Ubuntu operating system. You can find few tutorials on YouTube about how to install Minikube in Windows operating system. Just try it out once and let me know in case if you are finding any complexity. Then I will try to cover one more session for Windows setup. Okay. In this tutorial, I will guide you how to install Minikube in Windows operating system, and also I will demonstrate how to deploy your first Spring Boot application in Kubernetes cluster. Okay, I am supposed to demonstrate this using Mac operating system, but it seems maximum viewers requested to do the same on Windows. So if any Mac user is watching this video, don't worry, I will cover a separate session for installing Minikube in Mac operating system. Okay. Before we install this Minikube, first let's understand what this Minikube is and why we need it, right? So let me quickly brush up the basic architecture of pod, node and cluster to explain you why we need Minikube. As we know, in Kubernetes we have a cluster, and inside this cluster we can have either single node or we can have multiple node, and inside this node we can have a single pod or we can have multiple pod inside this node, and again inside this pod either we can have a single containers or we can have multiple containers, and this container is the platform where you can run your application. The application can be Spring Boot or it can be Angular or any technology specific application you can run inside containers which is present inside pods. Okay, now if you understand this basic architecture, to run an application in Kubernetes you need this cluster infrastructure, like you need pod nodes in your machine, right? How will you get this infrastructure? That's where this Minikube utility or tool came into picture. To run Kubernetes cluster in your local machine or computer, you need to install this Minikube tool. Minikube runs a single node Kubernetes cluster on your machine so that you can try out Kubernetes for your daily development work. So if you install Minikube, then you will get a cluster and node. Then you can host any containerized application inside it. So let's try this out. First step, we need to install Minikube. So let me walk you through the steps of installation process. If I'll move to the next slide, these are the links we need to open to download all the required component or to set up Minikube in Windows operating system. Okay. So let me open all the link. I'll just copy this link. Then I'll go to my Chrome browser and I can open it. Let me copy all the required link. I'll also open the second one, install Minikube. Okay, so install and set up kubectl. So what kubectl is does, kubectl is a command line tool. Using kubectl we can connect to Kubernetes cluster from our local machine. Okay, so that's the reason first we need to install this kubectl command line tool. And for Windows you can directly download the latest release version. Just click on this. It will download the kubectl.exe. Now next step, you need to install the Minikube utility for Windows. Okay, so just click on this Windows. This is what installing Minikube. Just click on this. Now if you scroll down, you can find this Minikube Windows AMD 64, right? Just right click on it, open it in a new tab. Now if you scroll down, for Windows, yeah, this is what for Windows, right? Minikube Windows AMD 64.exe. Just download it. Once you download this, then as per the documentation, rename it to the minikube.exe. Okay, so let me go to the download folder. Then I'll just rename this to the minikube.exe. Just click on the rename and I'll just add Minikube. So I can remove everything here. Fine. Now the next step, Minikube and kubectl, these are the two exe file you downloaded. Now let me copy these two files. Then I will create a separate folder inside any directory. So I will just create a folder inside C. Now I will just create a folder with name. Let me open the folder. I'll just name it Minikube. Inside this particular Minikube folder, I will paste these two exe file. Okay. Now go to the download. I just want to delete these two. Okay. Now if we'll go inside the C, inside the Minikube, we have these two exe file, kubectl and Minikube. Okay. Now to access this kubectl and Minikube, directly from the command prompt, I need to set this path to my environment variable, right? So just copy this and just type in command prompt environment. You can see here edit environment variable for your account. Just click on this, then click on path, click on edit, just add a new, just paste it. Okay, C colon minikube. Now click on OK, click on OK. Let me close this. Now let me open a command prompt. Then here I'll just type minikube version. So if you observe, this is what the minikube version we just installed, right? And we can able to see that particular version. Now we are done with the minikube setup in Windows. Now the next step, you need to start this minikube. So to start a minikube, there is multiple drivers provided by Kubernetes. You can use any of them. Let me tell you all the available driver to start a minikube. Now if you will go up, installing minikube, there is a multiple driver. You can use Hyper-V, you can use VirtualBox, or you can use Docker. Now this Hyper-V will not applicable for all the Windows version. If you are using Windows 10 Enterprise or Windows 10 Professional or Windows 10 Education, then only you can use this Hyper-V driver. Okay. If you want to use the VirtualBox, you should have enough space on your machine. Minimum you should have 16 GB RAM to use this VirtualBox. Since I have installed Docker on my machine earlier, I can directly use the Docker as a driver to start the minikube. So to start minikube with Docker driver, I can directly copy this command. Then I need to go to the command prompt, then paste it, and then change the driver as a Docker here. Okay, but make sure Docker must need to be installed on your machine and it will up and running. Okay, now let me run this command. It will take few seconds or few minutes to start the minikube. Minimum for me it took 2 to 3 minutes when I tried it before. So let's wait it to complete. If you observe here, preparing Kubernetes, this is what the version. Okay, on Docker 20.10.7, this is my Docker version. Okay, so it almost took more than 3 minutes. Let's wait it to complete. So if you observe, done. Kubectl is now configured to use minikube cluster and default namespace by default. So it took around 4.5 minutes for me to start this particular minikube. Now to verify minikube started successfully, you can check minikube status. Just enter it. You can see here host running, kubelet running, API server running, and kubeconfig configured. You should see this status. Okay. Then you can confirm that your minikube started successfully without having any error or any issue. So we are good here. We started the minikube. Now as per the documentation, we understand once we start the minikube, it will just create a single node cluster, right? So to verify that whether it created a cluster and a single node or not, what I can do, I can just type minikube, not minikube, kubectl cluster info, so that it will show me the information about cluster. You can see here Kubernetes control panel is running this, kubedns is running this. This is what my cluster info. Now let's verify the node. It should provide us a single node, right? So you can fire a command kubectl get node. You can see here the name of the node is minikube, status is ready, these are the roles, and age, these are the version. So as per the minikube documentation, it just provides us a single node cluster. This is what the node and this is what the cluster. Now we are done with our setup, Kubernetes setup in our local machine. Now we are good to go with the deployment. Okay. So let's quickly create a Spring Boot project to deploy that to the Kubernetes cluster. Now let me go to my IntelliJ IDE. Already I created one small hello world kind of example where I have only one endpoint and I am just exposing a string message here. Okay. Congratulations, successfully deployed your application to Kubernetes. And also if you observe, I just created a Docker file. Now the first step, I need to Dockerize this particular application. Then from the Docker repo, I just need to pull this image and I just need to run it inside Kubernetes cluster, right? So first I need to Dockerize this application. Now how Kubernetes will read your Docker repository? So to allow Kubernetes to read your Docker repository, we need to run a command. We just need to fire a command minikube and tell the environment which I am using. Okay, just enter it. Next, just copy the last one and just add it, then execute it. Now Kubernetes can read your local Docker repository. Now if I'll type Docker images, you can see these images specific to the Kubernetes. Kube proxy, Kube API server, Kube scheduler, Kube controller manager. These are the master node components, right? Then Kubernetes UI dashboard, etcd, metric scraper, something. There is lot of Kubernetes images, right? Now we give permission to Kubernetes to read my Docker repository. Now we can create the Docker image of our application. So what I'll do, I'll just move to the particular directory where I have this Docker. So I'll just copy the path here. From here I can directly move to that particular directory. Okay, let me clear everything. Now I just need to build a Docker image of this particular application Spring Boot K8s demo, and we have the Docker file here, right? This is the Docker file. Now let me go to the command prompt. So here I will just type docker build -t, then give the image name. So I will just give Spring Boot K8s demo or something like that, and I will just specify the version 1.0 and root directory. Just enter it. It will take few seconds. It is creating the Docker image. Yeah, so if you observe, it created the Docker image. Now to verify that, you can type Docker images and you can see this image, right? This is just what we created 12 seconds ago. Okay, so we have the Spring Boot image with us. Now we just want to run this particular image inside the pod, right? So for that, you need to create a deployment object. As you know, deployments are Kubernetes objects that are used for managing the pods. We can describe deployment object details using YAML file, or you can directly use the command prompt. For this example, I will just use the command prompt. In my next tutorial, I will show you how you can create the deployment and service with the help of YAML configuration. Okay. Now let's quickly create a deployment object using the command prompt. So I can directly type the command kubectl. Okay. Then create deployment. Give the name of your deployment. So I'll just give Spring Boot K8s. Okay. And just tell Kubernetes to read your image, which is the Docker image, right? So I can just specify image, give the name of your image, which is Spring Boot K8s demo, paste it and give the version as well 1.0, right? And then specify the port, which is 8080. So with the above command, we are telling to Kubernetes create a deployment with name Spring Boot K8s, okay, and then read the Docker image, which is Spring Boot K8s demo with the version 1.0, and run this inside a pod. Okay, so just enter it. It will create a deployment for you. So you can see here deployment.apps Spring Boot K8 is created. This is what my deployment object created. Now let me zoom this. Let's verify the deployments. Okay, so you can type kubectl get deployment. You can observe here this is what the name of the deployment, and the status you can see it's in ready state. Okay, one by one, and up to date one, available one. This is what the age. Fine. Now you can describe your deployments. You can see all the replicas and everything, all the description about your deployment. So you can just type kubectl get deployment description, or kubectl describe deployment, and give the name of your deployment, which is Spring Boot K8s. So you can see this is what the description of your deployment. You can see here, right? New replica set, one by one replica set was created because you didn't specify the replicas. And then this is what the deployment controller scaled up replica set Spring Boot. This is what the pod you can say. Okay, I will show you the pod as well. Now to ensure that Kubernetes successfully pull my Docker image and run it inside a pods, we can execute a below command kubectl get pods. You can check the status of your pods. Just enter it. You can see here this is what your pod name, and one by one status is ready, and you can see the status is running here. Fine. It means the Docker image which we created, Kubernetes is able to pull that particular image when you create the deployment object, and it created a pod, and inside a pod it just started a single container, and it just execute your particular image. To verify that, what I'll do, I'll just check the log of this particular pod. Okay, I'll just type kubectl logs, then give the name of your pods. You can see here it started your Spring Boot application. Now your Spring Boot application is running inside the pod container. Now you should have any option, or you should find a way to access that particular URL, right? So what we can do, we need to create a service object, and to create a service object we need to expose the current deployment with specific service type. Okay, so that the application can be accessed outside from this cluster, right? So what I need to do, I just need to expose the deployment which we just created. So if you type kubectl get deployments, so this is what the deployment, we just need to expose that particular deployment to create a service object, right? So what I can do, kubectl then expose deployment, give the name of your deployment, just paste it, and then specify the service type. So if you remember, while explaining the component of Kubernetes, I mentioned there is few service type like node port, load balancer. There is few service type, right? So in this particular example, I'll just use the node port. Okay, service type is node port. So kubectl expose deployment, name of your deployment, then specify the service type. Just enter it. You can see here service Spring Boot K8 is exposed. Now if I'll type kubectl get service, you can see here, right? This is what your service name, and the service type is node pod, and then this is what the cluster IP, external IP, and this is what the port we are exposing, right? Now what is the role of this particular service here with type node port? As you know, all the traffic will come to the service first, then service will redirect your request to the corresponding pods based on available. That is what we understand about service component, right? And this is what the service we created. Since we have only one pod, we can directly get the service URL to access that particular endpoint. So for that, what I can do, I can directly use minikube, give the service name. So I'll directly give the service name, Then you can add the service name here, get the URL. Just enter it. You will get the service URL or proxy URL to access your endpoint. Starting tunnel for service Spring Boot K8s. This is what the URL with which you can able to access your container which is running inside a pod. So let me copy this URL. Both are the same URL. You can copy any of them. Copy this. Go to the browser. Open a new tab. Then paste the URL. You are getting the 404 Spring Boot related error, right? Now just verify the endpoint. Go to your controller class. This is what we dockerized this particular application, right? So I'll just try the same endpoint. Let me add it here. You can see we are getting the message here. Congratulations, you successfully deployed your application to Kubernetes. And this is what we are returning from our endpoint, right? So now we are able to access the containers from which is running in our Kubernetes pod. Now also you can visualize health or status of your each component pod node of your Kubernetes. So to check the health, what you can do, I can directly use the dashboard, Minikube dashboard. Okay, so let me kill this. I'll just run Minikube dashboard. This is just an user interface where you can see all the node and their status, like all the components and their status. It will take few seconds to show you the Minikube dashboard or Kubernetes dashboard. So if you observe, this is what the dashboard URL. Let me copy this dashboard URL. Then it's opening in my default. Let me close this. I just want to open it in a Chrome. Let's go to the Chrome. Open a new tab. Just paste it. Okay, and run it. Yeah, so if you observe, let me minimize this. This is what my Kubernetes dashboard. Here you can see the deployment object, pods and replica set. So only we are not creating any replica set as of now. We have a single replica set is running, which is single pod. Okay, this is what the deployment object. You can see all the memory and resources related stuff. Now click on workload. These are the pods. Now there, as I already explained while explaining the component of Kubernetes, there is a concept called self-healing in Kubernetes. It means if I delete a pod, then immediately it will start a new pod. So I'll just show you that as well. See this, it's just started a new pod. Now if I'll show you the logs, it's starting the Spring Boot application again. It means it just started a new pod with a new IP address. That is what called self-healing in Kubernetes. Now in 20 seconds it's up and running. You can see here. It's now green status. And we don't have any replica set as of now. Even we didn't create any namespace. And we are using default namespace. Okay. You just deploy your code to the Kubernetes cluster and then start exploring more about this Kubernetes dashboard. There is lot of component mentioned here like job, pods, deployment, daemon sets, ConfigMap. We'll explore all the component one by one. Okay. So whatever the steps I mentioned in this video, same I already explained over the Medium blog. I'll share this link in video description. You guys can refer this. In my next tutorial, I will show you how you can deploy your Spring Boot application to the Kubernetes. We'll do the same example, but rather than using command prompt, I will just show you how you can use the YML configuration to create deployment object and service object. Okay, so before end this session, let's clean up all the components which we created. Go to the terminal. Let me do the Ctrl Z, Ctrl C. Just type CLS. Now we just need to delete the deployment. We just need to delete the service, everything. Okay, so you can just type kubectl delete service. Give the name of your service, which is Spring Boot K8s, or there is something like Spring Boot, right? Spring Boot K8s. Similar way, we need to delete the deployment. So let it complete first. You can see here service Spring Boot K8 is deleted. Now we just need to delete the deployment. Sorry, I typed the wrong command. It should be delete deployment. Yeah, so we deleted the deployment. It's not mandatory to do this, but it's good to do the cleanup. Okay, because in our machine we don't have enough space to keep those information. Now, if you'll verify kubectl get pods, we don't have any pods. Okay, now if we'll type kubectl get service, we have only Kubernetes service which is up and running. We don't have any other services. Similarly, you can verify get deployments. We don't have anything, right? Now the next we need to stop the minikube. Then we can delete the minikube. So to stop a minikube, we can type minikube stop. So once you run this command, it stops a local Kubernetes cluster. Okay. Then let's wait it to complete. So you can see here one node stopped. Okay. Now if I'll type kubectl get nodes, we are getting this error because there is no minikube which is in started mode. Okay. Now I just need to delete the minikube. So I can type minikube delete. It will delete a local Kubernetes cluster, and this command also delete the VM and it remove all the associates file. Okay. You can see here deleting minikube in Docker, deleting container in minikube. Okay. It will take few seconds to stop and delete the minikube. Yeah. You can see it remove all the associate file and VM. Before we install minikube, first we should know what is this minikube, right? So minikube is a tool that lets you run Kubernetes on your local. Minikube runs a single node Kubernetes cluster on your personal computer or machine so that you can try out Kubernetes for your daily development work. Okay. Basically this minikube will provide you a single cluster where you can deploy your application. Now let's begin with the installation step. If you'll search install minikube on your browser, you will find this link. Go to the second link, install minikube Kubernetes. Let me open this link. Here you will find all the steps to install minikube for all the operating system. You can see for Linux, macOS and Windows. So just click on macOS. First step, you need to check whether virtualization is supported on your Mac or not. So for that, just copy this command. Okay. Then you just need to open a terminal. So just type command and space. It will show you the spotlight. So you just need to type here terminal. Fine. Then just paste the command and enter it. You could see here BMX, which is highlighted, right? It means if you can see this BMX, virtualization is already enabled on your Mac OS. Now the next step, you can see here installing minikube. So just click on this Mac OS tab, and here you can see before you install minikube, first you need to install this kubectl. As you know, kubectl is a command line tool or command line interface through which we can connect to the Kubernetes cluster from our local machine. Okay, so first we need to install this kubectl. So you can directly install through this link. Just open the link. It will guide you the steps to install kubectl. So you can see install kubectl on Mac OS. You can directly download the binary distribution using this call command, or if you are using homebrew, then you can directly install using brew install kubectl. Okay, so I hope everyone aware about what homebrew does. If not, just let me recap once. Homebrew is a free and open source software package manager in Mac that simplifies the installation of software on Mac OS as well as the Linux. So if you don't know how to install homebrew, just type homebrew and go to the first link. This is what the official page of homebrew. Just click on it, and this is what the missing package manager in Mac OS. Any software or tool you can directly download through this homebrew, and you just need to fire the command brew installed, then that particular software name. If this home brew is not installed on your machine, just copy this link, go to your terminal, and you can directly paste it and run it. Next, this homebrew will be installed on your machine and you can download any software. Okay, so I'll just use the homebrew to install this kubectl. Let me copy this command, then go to the command prompt, just paste it. It will download kubectl on my Mac. Running brew update pre-install. So it's already downloading. You can see here. It will take few seconds. Yeah, you can see here. It already installed kubectl on my machine. You can verify the version of your kubectl. You just need to type kubectl version. Okay, just enter it. You can see this is what the kubectl client version we are using. Okay, now if you will move to the next step, we just need to install a hypervisor. If you do not already have a hypervisor installed on your machine, install one of these now. You can install hyperkit, you can install virtualbox, or if you want you can install VMware Fusion. Okay, you have another option, you can go with Docker as well. Okay, for this particular example I will use the hyperkit, and I can directly install this hyperkit through brew command. Okay, let me go to the terminal and I will just type brew install hyperkit. Okay, just enter it. You can see here running brew update pre-install and it's downloading. It will take few seconds to install. Yeah, you can see here it already installed hyperkit. Now to verify this kubectl and hyperkit both are installed on your Mac, you can simply type brew list. It will show you all the software installed on your Mac. You can see here hyperkit and Kubernetes CLI, which is nothing the kubectl. Fine. Now the next step, we need to install the minikube. We have the kubectl, which is command line tool. We have the hyperkit, which will help you for a virtualization. Now the next step, we need to install the minikube. So I can directly use the brew command, brew install minikube. Okay, just enter it. It started the download. You can see here. Yeah, it also installed the minikube on my machine. Now to verify the minikube version, what you can do, let me clear all. You can search minikube version. This is what the particular minikube version we are using. Fine. Now the next step, we need to start the minikube. Now if you will scroll down, there is a command to start minikube. Minikube start, then you can specify the driver name. So as part of driver, you can specify either hyperkit, virtualbox, or VMware Fusion. If you will not specify anything, then whatever the default installed on your machine, this minikube will take that particular driver and it will start the minikube. So let me start this minikube without specifying any driver. So I will copy this link. Then let me go to the terminal. Let me zoom this. Yeah, I'll just copy this command and paste it. Minikube start. Then just click on enter. If you observe, automatically it selected the hyperkit as a driver. Okay, since I have only this hyperkit installed on my machine, so it directly take this. If you have any option VMbox or VMware Fusion, then it may ask you to choose the driver which you want, and it will take few minutes to start the minikube. So let's wait it to complete. Starting control panel node minikube in cluster minikube, creating hyperkit VM. This is where the memory allocation. Preparing Kubernetes, then generating certificate and keys. It will do some inbuilt steps to start the minikube. Putting up control panel. You can see here, and it started the minikube. So to verify it started the minikube, what I will do, I'll just type a command minikube status. You can see here host running, kubelet running, API server running, and what is this? Kubeconfig is configured. Fine. Now what we can do, as you know, Minikube will provide us a single node cluster. To verify when we start the Minikube, it provided us a cluster. I will just type kubectl cluster -info. This is what my cluster info. Okay. And to verify it provided a single node, I can just type kubectl get nodes. You can see here it provided a single node. Fine. So we successfully installed Kubernetes in our macOS system. Also we verified after starting the Minikube, it is giving us a single cluster and a single node. Fine. Now in my next tutorial, I will show you how we can deploy our first Spring Boot application to this Kubernetes cluster using YML configuration. So as you know already, this Minikube is started on our machine. If you want to continue, you can use directly this Minikube. Otherwise, you can directly stop the cluster which is running through this Minikube. So to stop that, what you can do, you just need to type the command Minikube stop. It will stop the node which is running. So let me enter this stopping node Minikube. You can see here, right? It will take few seconds to stop the node. Yeah, you can see here one node stopped. Now also if you want to delete the cluster from your Mac OS, you can simply type Minikube delete. You can see here it deleted your cluster. Okay. So better to clean up always. Once you do the development with this Minikube on your local machine, it's good to clean up the resources. You just need to stop the Minikube and delete the Minikube. So whatever the steps I mentioned to set up the Minikube on our Mac OS, already I prepared a Medium blog. You can just search Medium JavaTechie. You can find the latest blog which I published about installing Minikube on Mac OS. I'll share this link in video description so that you guys can refer the steps. Yeah. So let's quickly create a Spring Boot project. Let me go to my IntelliJ IDE. If you observe, this is what the last example we deployed to the Kubernetes cluster using kubectl command, right? We are going to use the same example. If you observe, there is a single REST endpoint who will return some string message. Fine. Now at first step, we need to create Docker image for this Spring Boot application. So there is multiple way you can create Docker image of your Spring Boot application. You can directly use Google Zip library, or you can use the build pack of Spring Boot. I will go with the traditional approach. I will just create a Docker file. So if you go to the Docker file, I am using JDK8 and this is what the port I am exposing my API or my containers, and this is what the jar file name, and this is what the command to execute my jar file. Okay, with the help of this Docker file, we'll create Docker image of our Spring Boot application. But first step, we need to start the Minikube. Then you need to allow Kubernetes to read your local Docker repository, right? So first let's start the Minikube. You can just type terminal. Let's search the terminal. Then in terminal you can simply type Minikube start. Okay, just enter it. It will take few seconds to start your Minikube. So if you observe, it started your Minikube. Now to verify that, what we can do, we can type the command Minikube status. You can see this component host is running, kubelet also running, API server is also running, and kubeconfig is configured. Okay. Now we need to allow Kubernetes to read our Docker repository. So for that we need to fire a command eval. Then you just need to add a dollar symbol and just specify Minikube environment. Okay, which is Docker. Just enter it. Fine. Now you need to go to your project directory to create a Docker image. So I will just move to CD. Then it will be in desktop folder. Fine. JavaTechie code base. Then Spring Boot K8s. Okay. Fine. Now in this particular project directory, I have my Docker file. To verify that ls-l, you can see I have the Docker file. Now I can create the Docker image. So what I'll do, I'll just type a command docker build -t. You can give the name spring boot k8s -example, then give the version. I'll just give 1.0, or you can give the latest, then specify the current directory. It will create a docker image now. It will take few seconds to create the docker image. You can see here it's downloading, it executing all the steps whatever we mentioned in docker file. So if you observe, it created the docker image. Now to verify that, what you can do, you can type docker images. You can see this image, right? Spring Boot K8s example, and this is what the tag we added 1.0. Fine. Now that docker image is created, now we need to deploy this particular docker image to Kubernetes cluster. And to deploy this particular docker image to Kubernetes cluster, we need to create a deployment object. If you remember, in previous tutorial, we created this deployment object using kubectl command, right? Now the best way to make this deployment in Kubernetes is by preparing YAML file, which is industry standard. By configuring this YAML file, or by creating this deployment YAML file, we are telling to Kubernetes to create instance of my Spring Boot application in Kubernetes cluster, or we are telling to Kubernetes just create a Spring Boot image in my Kubernetes pod and just run it inside some containers. That's what we need to describe as part of the deployment file. Okay, so let's define deployment specification. Let's go to your application or IntelliJ IDE. We just need to create a file. So you can create it anywhere. For now I am just creating it in the root directory. Just name it deployment, or you can give any name. Okay, I will just name it k8s deployment.yaml. Fine, just enter it. Now here you just need to provide all the information so that Kubernetes can read that and he will run your particular application to the Kubernetes cluster. So let me add the content of this deployment.yaml file. So I'll just explain each and every key attribute of this YAML file. So this API version is nothing, it describes the version of your API server, and the kind is nothing, you are telling to Kubernetes that this is what the type of object I am creating. For deployment, you specify deployment. If you are going to create the service object, you need to provide this kind as a service. Okay. Next, metadata. This metadata describes information about the application name and labels. So you can see here there is a name of metadata. You can give any name, and there is a key called spec. Inside that there is a selector and labels. So on short notes, you can group multiple pods inside a single service. So that's the reason we are using the selector and label. So I will cover this particular concept selector and label in my upcoming tutorial. For now, you just understand this selector and label should be same in deployment and service as well. Okay, so you just remember this name syntax Spring Boot K8s. And if you observe here, there is something called replicas. We are just telling to Kubernetes create 2 pods of my application in Kubernetes cluster. If you want 4, you can just mention here. Okay, so I'll just change it to 3 so that 3 pod will be created for my application. Fine. Now if you scroll down, there is something called template. Again, inside the template you can find the labels, and this name should be same, means this label's name. Fine. Now inside the spec you just define the container, and you are telling Kubernetes this is what my name of container, and this is what the image you need to fetch from my Docker repo. So you just need to update the image name. Let me go to the terminal and let's copy the proper image name. Spring Boot K8s example. Let me copy this. Fine. Just remove the space. And you're specifying the image pool policy if not present. This image pool policy, if you will not specify, Kubernetes will search your Docker image in Docker Hub. If you will specify image pool policy if not present, first it will check in your local. If it is not present, then it will fetch from your Docker Hub. Fine. Now you can see here there is a port. So container port is 8080, the port that the container is running on the cluster. This is what all information you need to provide as part of deployment object by creating a separate YAML file that is called deployment.yml file, or you can give any name to that file. So hope all the keys are clear for you. what you need to mention as part of your deployment. Now to create this deployment object, what you need to do, go to the terminal. Already we created this YML file. Now if I will, let me clear this. I'll just type ls-l. You can see this deployment file we just created, right? We just need to create the deployment object with the help of this file. So how I can create that? There is a simple command in kubectl or Kubernetes. You can type kubectl apply, then type file name, which is k8s deployment.yml file. Just enter it. You can see here Spring Boot k8s created. It created the deployment object. Now to verify that, what I will do, I will just search kubectl get deployments. Fine. You can see there is 3 pod running for my particular application. That's the reason we created replicas 3 in our code, right? That's the reason there is 3 instance you can see here. Now go to the terminal and let me add enter. We can directly check here kubectl get deployments, and then since there is 3 instance, let me check the pod kubectl get pods. You can see here there is 3 pods running. It means for a single application there is 3 separate instances running in 3 different pod with different IP address, isn't it? So here you can also verify whether your pods is running successfully or not by checking the log of your pod. So you can copy the name of your pod and you can type kubectl logs, then you can give the name of your pod. Okay, the type is mistake, kubectl logs, just add the pod name, just enter it. You can see here the application started on port 8080. Similarly, you can check your another pod, get logs, kubectl logs, then give the pod name. Fine. The second pod is also running smoothly. Now let's check the third pod, kubectl logs, then give the pod name. Fine. Now our application is running smoothly inside Kubernetes cluster. But we have a challenge here. If you observe my application running on 3 different pod, I mean 3 different instance, right? So if you'll check here again, kubectl get pods, there is 3 instance of my application, isn't it? Now the challenge here, how can I consume my application? If I send request to access my application, where does this request will land? Whether it will go to the first pod or second pod or third pod, we don't know, right? And how Kubernetes also know where to send the request, since there is 3 different instances. Now to solve this kind of challenge, we need some load balancer mechanism, isn't it? That's where Kubernetes provides us a specific component, that is service. In Kubernetes, service plays the role of service discovery, where it exposes our application to outside the world or to outside the Kubernetes cluster, as well as it acts as a load balancer, where it decides which pod should handle the request. If a user sends the request to the application, since there is 3 instances running, Kubernetes service will decide to whom he need to send that particular request, whether it is pod 1 or pod 2 or pod 3, based on the load availability. Okay, that's the reason there is a separate component which is service, and you can create this service with the help of YML approach. Now let's quickly go to the IntelliJ IDE and let's create the service definition. So just right click in the project, click on new file. You can give any name, guys. I'll just give k8s service.yaml. Fine, just enter it, and then let me add the information. So if you observe, I'm just giving the API version, which is nothing v1. This is what the Kubernetes API version, and this is what the kind I am providing, or I am just telling to the Kubernetes. This is what my service component object. If you remember, in deployment we just mentioned kind deployment object. Okay. Similarly, what component object you are creating, you need to mention that as part of kind. Now next metadata, and as part of metadata, it take the name of your service. You can give any name here. Okay, I'll just give service Spring Boot k8s service, and then spec selector. If you remember, the selector name should be same as your deployment selector. Okay, you just need to remember this. Then the next component or the next key attribute is ports, where we just provided the protocol which is TCP, and we provided the port 8080. This port that the service is running on in the cluster. And again you need to specify the target port, the port exposed by the service. Okay, and this is what the last key which you need to remember, type of service. So if you remember here, I am just using the type as a node port. It means I can able to access my API with the help of node IP and node port. There is different kind of service. If you remember, I explained the type of service while explaining the component of Kubernetes. So there is also service type cluster IP, and there is also service type load balancer. Okay, so these are the three service type available in Kubernetes: node port, cluster IP, and load balancer. I will cover a separate session for each service type. For this example, we'll use the node port so that we can able to access our application with the help of node IP and port. Okay, now that we created the service file, let's expose our app to outside Kubernetes cluster. We just need to expose this particular service. Okay, so what I need to do, I will just go to the terminal and I will just type. So let me scroll down, or let me clear this first. Fine, I'll just type kubectl apply hyphen file name. Then I will just give the file name as k8s hyphen service dot yml file. Okay, just enter it. Okay, so there is a spelling mistake. So what I'll do, I'll just add the kubectl. So just go to the begin, just add the e kubectl apply, then file name. Just enter it. If you observe, it created the service. Fine. Now let me zoom this. Let me clear this. Fine. Now we just need to check the service. Kubectl. You can type get service, or if you want, you can type kubectl get SBC. Okay, both will work. And if you observe, this is what the service, and the service type we are using node port, and this is what the cluster IP. Fine. And if you see, this is what the port of your node 32208. With the help of this port, you can able to access your API. Now to verify the node IP, what I will do, I will just type kubectl get nodes hyphen o wide. So if you observe, this is what the IP address, and this is what the port. With the help of that, you can able to access your endpoint which is hosted in Kubernetes cluster. Fine. Now since we exposed our service as a node port, we need node IP. Also we need node port to access the API. Fine. So let's copy this node IP. This is what the node IP, but if you want, you can also check the minikube IP. Fine, you will get the same. See this internal IP and minikube IP both are same. You can use this minikube IP as well. Fine. Now let me go to the browser, and first let me copy this IP. Let me copy this, and the port is, what is that port? 32208. Fine. Go to the browser, just type HTTP, then just add it, then give the port. What is that? I forgot. 32208, I guess. Okay, yeah, 32208. Let me copy this, add it. We are getting Spring Boot error, right? Now let me add the endpoint message. If you observe, that is what the endpoint we exposed, right? Slash message. Now go to the browser. This is what we are getting the output. You can see here. That is what the output we are getting. So we successfully hosted our application to the Kubernetes cluster using YML configuration of deployment and service object. Now let's check the status of each component in our Kubernetes dashboard. Okay. So for that, what we need to do, we just need to type minikube dashboard Fine. It will just open a dashboard where you can see all your component. So it will take few seconds. Yeah, you can see here we don't have any namespace, so that's the reason it's showing default one. We didn't create any namespace yet. Okay, I will cover a separate session with the namespace. Now you can see here there is 3 pods running because we created the replica as a 3, right? The count is 3. Or let me zoom this actually. Yeah, you can see here the count is 3 here. Now similarly there is replica set, one replica set with 3 pod, that is what is there. Now you can directly check each component from here. You can check the deployment. This is what the deployment object we created, right? So if you will check the name and if you will go to your code and if you will check your deployment.yml file, the name of your deployment we provided this Spring Boot K8s. Fine. That's the reason this is what the name displaying here. Now let's check the next component, which is pod. Okay, just click on this pod. You can see there is 3 instance, 3 pod is running for our application because we created replicas 3. Fine. Now let me minimize this. Let's say I just want to delete one pod. Immediately it will Kubernetes will restart a different pod. You can see here it just restarted. One is terminating. You can see here status is terminating. It got removed. Let me retry it. Let me delete this. Okay. Let me yeah, you can see here the status is terminating and again it just started. Now if you'll see the log, it's running. Check the logs. You can see here it started the Spring Boot from begin. Now click on the pods again. The status is running. If you'll see the log here, see here your application started 8080. Fine. This is what the concept of self-healing in Kubernetes. I believe I already explained this concept. Now you can check other. If you click on replica set, you can see this is what the replica set. And if you click on service, this is what the service name we created, right? And you can see the service. This is what the cluster IP, service type is node port. All the components information you can find here. Okay. So this is what we just deployed a small application to the Kubernetes cluster with YML approach. So going forward, we'll use this YML approach to deploy our application to the Kubernetes cluster with different components. Okay. So in my next tutorial, I will just guide you how we can deploy a CRUD application to Kubernetes. We'll use Spring Boot MySQL with Spring Data JP. So before we start deploying our CRUD application to Kubernetes cluster, once again, let me recap the steps. We created a Spring Boot application, then we built Docker image of our Spring Boot application, then we created deployment object using YML configuration, where we tell to Kubernetes, take this Docker image and run it inside Kubernetes pods, right? Then we created service object. With this service object, we inform to the Kubernetes, expose my application to outside Kubernetes cluster so that user can able to access it, right? These are the basic steps everyone must need to follow to deploy their application to the Kubernetes cluster. Now in our application, we are going to integrate MySQL database, right? So here we need to run database instance in different pods inside Kubernetes cluster. So what we need to do, the way we deployed our Spring Boot app to the Kubernetes, similar steps we need to follow for database instance as well. So at first step, you need to pull MySQL image from Docker Hub. Then you need to create the deployment object and tell Kubernetes to take this MySQL image and run it inside a separate pods. Then you can create a service object so that you can expose your DB instance outside to the Kubernetes cluster so that your Spring Boot application can connect to that MySQL DB instance. And now if you look at high level, then inside a node there will be 2 pods. One pod will run our Spring Boot application and another pod will run our MySQL instance. Okay. So as per the PPT, let's follow the steps. We'll follow this particular PPT. At first step, we need to create a Spring Boot CRUD application. To save our time, already I created one small CRUD application where I just exposed 3 REST endpoints. One is post mapping, will save the order object to the database, and one will fetch all the list of order from DB, which is get mapping, and another get mapping will fetch the order based on the ID. Okay. And if we'll check the pom.xml, we just added what is that, Lombok dependency, MySQL connector, Spring Boot starter web, and JPA. That's it. These are the dependency we added in our pom.xml. Now before we deploy this CRUD application to the Kubernetes, first let's test this application in our local. So what I'll do, I'll just start the main class, just run this application. So if you observe here, application is started on port 8080. Now let's go to the controller and we have the endpoint slash orders. Okay, let me go to the postman. Before that, let me go to the entity to see the request structure. We have ID which will be auto generated. Then we have name, quantity and price. Go to the postman. So let me go to the post request. So I'll just add a new order object. I'll just give it, let's say, watch quantity 2 1499 or something. Okay, now click on send. The record got saved in DB and the ID I am getting 4 because already I inserted few record to this particular database. Okay, now to verify that, I will just do the get API call. You can get these are the object. Fine. So our application is working as expected, right? All the endpoint is working. There is no error or there is no exception. Now the next step, you need to dockerize your Spring Boot CRUD application. So to dockerize this Spring Boot CRUD application, I just need to add the Docker file. So this is where the Docker file. I specify from and expose port. Then this is where the target where my jar is located, and this is where my entry point to execute the jar. This is where the command to execute the jar file. So now if you will deploy this particular Spring Boot CRUD application to the Kubernetes, it won't work because no database instance is running inside Kubernetes pods, right? So if you can remember the presentation, my Spring Boot application need to connect to the MySQL instance which is running in Kubernetes pods, right? So far we didn't deploy any MySQL instance to the Kubernetes cluster. So at first step, we need to deploy MySQL instance to Kubernetes pods. Then we need to deploy our Spring Boot application. So let's follow the steps 2 directly. Let's pull the MySQL image from Docker Hub. So before that, what I need to do, I just need to start my Minikube. So I'll just go to the terminal. Simply I can start here Minikube start. I can type this command Minikube start. It will start the Kubernetes in my machine. Okay. So if you observe, my Minikube is started. Now I just need to sync both my Docker and Minikube. So if you remember, we execute this command eval, then just add the dollar symbol here, not there, just type here. Fine. Then you just need to specify the environment. Minikube docker -env. Okay, just enter it. Then you can check Docker images. I can type Docker images. You can see all the available images here. Okay, so these are the images. Now first we need to pull the, if you can remember this presentation, first we need to pull this particular MySQL image from Docker Hub, but we are not going to do it manually. While creating the deployment object, we'll just specify the latest MySQL version so that Kubernetes deployment object will take care to pull that image and it will just execute in a separate pod. Okay, now as per the presentation, we just need to create the deployment and service object using YML configuration. So if you didn't watch my last tutorial of Kubernetes Spring Boot application deployment to the Kubernetes, you must need to watch that, otherwise you will not get any clue about the deployment and service object. Okay, so I'll just follow the same YML configuration the way we did for our previous application. So to create or to run a MySQL instance in Kubernetes pods, we need to create the deployment object, and to expose that particular instance outside to the Kubernetes cluster, we need to create the service object. So I will just create a YML file in our application. I will just create it in a root directory. Let me create a file, let's say db-deployment.yaml. Okay, inside this file I just need to specify the deployment and service object of Kubernetes. So I have that template ready. Let me add it. I will explain each and every line. So if you observe this YML configuration, we are creating deployment object of our MySQL, and also we are creating service object of our MySQL. Apart from that, we are also creating another component which is persistent volume claim. This will tell Kubernetes to get the storage for running your database instance. Okay, that's the use of this persistence volume claim, and we are just specifying the metadata, and we are just adding the label, and access mode is read write, and this is what the capacity or storage we are asking to Kubernetes to provide that for running my MySQL instance. Then if you observe the next component, which is nothing, deployment object, and as part of deployment object we are telling to Kubernetes get the latest MySQL 5.7 image from the Docker Hub and just run it inside a Kubernetes pods where the root password is root, and create a MySQL database with name JavaTechie, and this is what the container port, and this is what my host, which is MySQL. Okay, and we are also specifying the volume mounts MySQL persistent storage. This is what the path we are giving to add the details or to store the object. Okay, and we are just pointing to the persistence volume claim which we created in our first component. This is what the alias we are giving here. Okay, that's what the deployment object we created for our MySQL. So let me show you. This is what the entire deployment object. Fine. Next, as part of service object, we are just giving the name of our service, which is MySQL service, and we are just giving the target port. And if you observe here, we are not specifying any service type. We are not specifying node port or API cluster, or we are not giving the load balancer. No service type specified for a MySQL database instance. And simply we are just telling to Kubernetes this is what the port where my MySQL is running. Fine. Now with this information we can start MySQL pods in Kubernetes cluster. So for that what we can do, first I need to go to the project directory, then I just need to execute this particular YAML configuration. Okay, so let me go to the terminal. Now let me go to that particular directory, cd, it is inside desktop, then JavaTechie code base, then what is the project name, Spring Boot, CRUD, KTS example. Okay, now here I can execute this particular db-deployment.yml file so that it will create all the required component. It will just create the pods for us so that MySQL instance can run over there. Okay, so I will just simply run this kubectl apply, give the file name which is db-deployment.yml. Okay, let me zoom this. Now I'll just enter it. So if you observe here, it created persistent volume claim, it created deployment object, also it created service object. Now to verify that, I will just check kubectl get deployments. This is what one deployment, still it's in ready state. Now if you check the pod of MySQL, kubectl get pods. If you observe, the status is container creating. We can check the log as well whether my MySQL instance started or not. I can type kubectl get, not get, logs. This is what the pod. Okay, so you can see here it's already completed. Now if I'll go above, yeah, let me check the pods now. Let me clear this. So you can simply run kubectl get pods. You can see here the status is showing one by one is running. Okay, previously that it was just showing the status container creating. Now it's one by one running. So now what I can do, let me go back. Then next we'll directly log into this particular MySQL pod to check the schema status. So for that I will just create another window for my terminal. Then I will just get the pod name of my MySQL. I will just type kubectl get pods. Okay, we'll just go inside this particular pod and we'll verify. So let me copy the name of my pod. I can go inside this particular pod or I can execute this particular pod using the command kubectl. Okay, execute hyphen integrated terminal, then give the name of your pod, then just add the slash bin and bsh, just enter it. You can see here. Now what we can do, we just need to log into the MySQL. Okay, so for that I can type a command mysql then give the host name, which is again MySQL, then give the username, which is root. If you observe, this is what my username, right? This is what the username. Now again, this is one also password. Root is my username as well as the password. Now go to the terminal. You can specify -p, which is root. Fine. Now if you observe, you are getting this MySQL. Now we need to show the all the database. So you can type show databases. You can see it created our database schema. Now I just need to use this particular database. Use JavaTechie. Fine. You can see your database changed. Now we verified that our MySQL instance is up and running. Now as per the presentation, the second segment is up and running. We can now start our Spring Boot application. We can deploy it to the Kubernetes cluster. But before that, if you go to your Spring Boot application and if you go to your application.yml file, here we configured our local database related configuration. JDBC MySQL localhost 3306. This is what which is running on my local machine. So we need to change this to the pod configuration, like the MySQL pod which is running on Kubernetes cluster. Those configuration we need to add here. Okay, the username and password, everything we need to change. So for now, let's make those field dynamic. Later we'll fetch those information from our app deployment.yml file. Okay. So for that, what I'll do, for this host, I can replace it to the dynamic value, which will be something like this, db host. Okay. Similarly, I can specify the database name. I can give something like db name. Just add the dollar symbol here. Same way I can add for username and password. Okay, let me copy this username, so I can change it to the username, and here also I just need to change to the password. You can add here use SSL false, SSL equal to false. Okay, now we can build Docker image of our Spring Boot application. But if you go to the presentation, so we just completed the segment 2. Now my MySQL instance is up and running in Kubernetes pods. First step, we completed the Spring Boot application as well. And then the next step, we need to create the Docker image. Then next, we need to create a deployment and service object of my Spring Boot application. So we are in the second step. Let's create the Docker image of my Spring Boot CRUD application. So just go to the IntelliJ IDE and let me stop this. Let me create a build, new build. Just wait it to complete the build, then we can quickly create the Docker image. Okay. So it will take few seconds to complete the build. Yeah, so build is completed. Now go to the terminal. I can directly go to this. Okay, so I'm inside the project directory. Let me clear this. I'm inside project directory. Let me type ls, so I can see this Docker file here. Fine. So I can now build the Docker image. Docker, better let me add enter. Docker build hyphen target. I can give the image name with the tag which is 1.0, then in the current directory. Okay. Now it will create the Docker image. So you can see here it created the Docker image. Now if you will check Docker images, I can see my Spring Boot CRUD K8s, and if you observe also you can see the MySQL images. Okay, so when we created the deployment object of MySQL, it pulled the MySQL image with the tag 5.7 from the Docker Hub. That's why you can see here this particular MySQL instance, and this is what the image we just created, Spring Boot CRUD. Okay, now if you'll go to the next step, we need to create the service and deployment object. So we just created the CRUD application, we build the Docker image of it. Now the next step, we need to create the deployment object and service object. So for that, we just need to create the YML configuration. Okay, so we added just one YML configuration for MySQL deployment, and we are going to add another YML deployment for our Spring Boot CRUD application. So I'll just create a file. I'll just name it app, or you can just give service any name. I can give app deployment yaml. So here for my Spring Boot application, I just need to create the service and deployment object. Okay, so let me add the template. I can add it here. So there is nothing complex. I just created the deployment object where I tell to the Kubernetes created 3 replica, means there will be 4 pods for this particular deployment object, and this is what the name of my deployment. Okay, this is what the name of my deployment, and this is what the selector. Now if you come down, this is what the image I am telling to Kubernetes get this image from my Docker and just run it inside a Kubernetes pods. And this is what we specified. This is what my DB host, DB name, DB username, and DB password. That's what we added in our application.yml file. These 4 properties will get bind from this app.deployment. Okay. So make sure whatever the key you passed here, same you need to configure in your application.yml file. Now if you scroll down, we just added the service. There is 2 objects we created for our app deployment and service object. So inside service object, we are just specifying the service type, which is node port, and we specify this is what the port and this is what the target port. Fine. And this is what the name of my service. Now what I can do, I just need to execute this app deployment.yml file. So it will just create deployment and service object of my Spring Boot CRUD application. So what I can do, I will just go to the terminal. Then I can type, let me zoom this. I can type here kubectl, okay. Then apply -f. You can give app -deployment.yml file. Just enter it. If you see here, it just created deployment object and service object. So now if I'll check the deployment kubectl get deployment, I can see there is 2 deployment, one for MySQL, one for my CRUD application. Now similarly, if I'll check the service get SBC, I can see there is 3 service, right? MySQL and Spring Boot CRUD. Now if I'll check kubectl get pods, let me clear it so that I can show you in better way. Now if you see the pods, there is 3 pods. That's the reason we created replica 3, right? There is 3 pod for my Spring Boot CRUD application, and this is what for MySQL. Now let's check the log for this particular Spring Boot CRUD pod. Okay, so what I'll do, I'll just check kubectl logs at the pod name. You can see here it created the Hibernate sequence, it created the table. You can see here it created the order table inside the MySQL instance, which is running inside Kubernetes pods. So you can check the log for all the 3 pods if you want. Let me check for the last one. You can again type kubectl logs. You can add it. You can see here the log. Okay. Now what we can do, let's check the node IP, because the service type which we exposed is node port, right? You can access it with using the node IP as well as the node port. So for that, what I'll do, I'll just use kubectl get SBC. Okay, kubectl. Let me clear this. Kubectl get SBC. This is what the port where my Spring Boot CRUD application is running, and I can get the IP. I can directly get the IP from node, or I can just type minikube IP. This will also give me the node IP. Okay, with this host or with this particular IP and with this particular port, I can able to access my Spring Boot CRUD application. But before access it, let's verify in the MySQL connection whether it created the database or not. Okay, so I'll just do exit. Then I'll simply log in again to the MySQL console. I'll just type MySQL, then give the host name, which is MySQL, give the username, which is root, then give the password, which is root again. Okay, now I'll just check here. So databases, database name is there. Now I can directly check. So tables. Okay, there is something going wrong. Let me check. So it's showing that no database selected. So what I'll do, I'll just use JavaTechie, then just fire the command show table. There is something going wrong. So yeah, so you can see here is the order table. Let me zoom this. You can see this order table is there inside the schema JavaTechie. That's what we changed here right now. Now let's go to the another terminal and we'll check the node IP and node port. So yeah, this is the node IP. Let me copy this, and this is the node port, which is 32473. Okay, go to your Chrome browser, then just type http localhost, not localhost, sorry. You just need to give the IP, then just add the port. Let me add the port again. Copy this, go back, just add it here. Then you can add your URL. Okay, for me it's orders. To check the get API, it is orders. I can just enter it. If you observe here, I am just getting here empty response. There is nothing, right? Because you didn't add anything to the MySQL instance which is running inside Kubernetes pods. So to add that, so if you first go to the controller, this is what the exact endpoint I am accessing /orders. I just checked for get to fetch all the list of order. There is no order object so far we added in the MySQL instance which is running on Kubernetes pods. So let's execute the post mapping, then we'll fetch the order. Okay, we'll just do the get call. So just go to the postman and let me add a separate endpoint post, or I can just change it here itself, right? I can just change the URL here. This is what order I am going to add. Click on send. It added the first order object where you can see the ID is 1, and then let me add another order. Let's say books. I'll give quantity 5 or 6. Price is 6000. Just send the request. You can see the ID is 2 and it got added. Now let me add some other products. Mobile, quantity let's say 2 and price is 10,000. Just add send. Just add something else. 2, let's say price is let's say 999. Send it. So we added 4 objects, right? Now let me do the get call to fetch all the list of order object. You can see here there are 4 order objects stored in the database. So to verify that, go to the table or MySQL console. You can type here select star from. Let me zoom this. Let's clear this first. Oh sorry, it's inside MySQL, right? I need to type select star from table name, which is the order tables, right? Just add the correct name. You can see we just added 4 object, and we can see all the 4 row here. Now if you'll go and check in your browser, you can visualize in better way. I will just search get call. I can see all 4 object here. Okay, and if I will search by ID, let's say I will give ID 1, I'll get the order object filtered by ID here. So here we successfully deployed our Spring Boot CRUD application to Kubernetes cluster. And once again, if you can recap once again, so we just deployed our MySQL instance in a separate pod, and we deployed our Spring Boot application in a separate pod. And my Spring Boot and MySQL node are connecting with each other because they both are inside a single node. This is what the high level diagram, right? Now let's check the health of each component. So for that, let's do one thing. I will just go to the terminal and I will just type here minikube dashboard. It will redirect us to the Kubernetes dashboard. So it will take few seconds. Yeah, you can see here. So there is 2 deployment. You can see here one deployment for Spring Boot CRUD and another for MySQL instance. And there is total 4 pod. One pod for MySQL and 3 replica. We created 3 replica. That's the reason for our CRUD application there is 3 pod and there is 2 replica set. If you will check the deployment, it is there. If you will check job, there is no job. You can see these are the pods. And also if you will check the service, you can see there is 3 service. One for MySQL, another for Spring Boot CRUD SBC, which is nothing service, and one is for default Kubernetes service. So we are good here. This is how we can deploy our Spring Boot CRUD application to Kubernetes cluster. And if you observe in the code, let me go to the IntelliJ. If you observe in the code in db-deployment.yml file, I hardcode my username and password. Correct? Everything I hardcoded here. My root username and password, my database name, host, everything I hardcode here. So in my next tutorial, I'll just tell you how you can segregate sensitive information of your application outside to the Kubernetes. So you can use the config map or you can use the secrets. Okay. So in my next tutorial, we'll demonstrate both config map as well as the secrets of Kubernetes. Hi everyone, welcome to JavaTechie. In the previous tutorial, we understand how to deploy Spring Boot MySQL CRUD application in Kubernetes cluster, right? But if you observe the code, we hard coded all data source properties in application. So if you will go to the app-deployment.yml file, you can see here we just hard coded DB host, database name, database username, and database password. These are the sensitive information of my application, right? Which is not a good practice to hard code. If you hardcode this kind of sensitive information in your code, then your application itself is not secure. So to avoid that, we should always keep that sensitive information outside of the application with encrypted format. Since we are using containerization platform, Kubernetes itself provides us two components to store these kind of inputs. So let's understand those two components which will help us to manage our configuration. Okay. So Kubernetes provide config map and secret as two separate components to store your sensitive information. I believe I already explained these secrets and config map while explaining components of Kubernetes. But let's recap once again. If someone not aware about these secrets and config map, you can get the context here itself. Okay. So there is two component, config map and secret. First of all, both are present outside of the pods. So within a node, all the pod can access to that particular config map and secrets. And the basic difference between these two, config map usually store information as plain text with key value pair pattern or key value pair format, where secrets store the information in encrypted text. This is what the basic difference between these two components. So now, as per our application design, we can keep our username and password inside secret because this must need to be encrypted, right? And then database host and database name, we can keep it inside config map because these two are not sensitive information, so we can store them as a plain text, right? So let's quickly modify our existing code, then we'll demonstrate behavior of config map and secrets. Okay, so let's get started. So now in our existing code, we need to create two more YML file. One is for config map and another one for secrets. So this DB host and this DB name, these two information will keep inside our config map as a plain text, and this particular DB username and DB password will keep inside a secret with encrypted format. Okay. So first let me create a config map.yml file. Just create a new file. I will just name it MySQL, then I'll just specify config map, any name you can give here, .yaml. Then here first I need to specify API version. Okay, I'll just give v1. Then you just need to provide kind. It means you are telling to the Kubernetes this is the object of config map. Fine. Next you need to provide metadata. As part of metadata, you just need to provide a name of your config map. So I will define a name db-config. You can give any name here. Okay. Now the next you need to provide the what all information you want to keep in this config map. Okay. So that's the reason I will just give data. Then what all information we want to set here, we just want to set the host and database name.
right? So I can give here something like db name, or you can give the name, anything you can give. Okay, so host is nothing our MySQL, because this is what the config map. Here we can store the information as a plain text, and this host and database name is not sensitive information of my application, so I can add them as a plain text. So this database name I will give JavaTechie. Okay, correct. Now let me copy this, then we'll create a secret.yml file. Let me create another file, new file, then I will just give the name mysql secrets.yml. I'll just copy this, then here you just need to provide the object name, which is secret. Okay, and then metadata you can give any name of your secret. I will just give mysql secrets. Then here we just need to provide the username and password, because this is what we just want to encrypt. So I'll just change the attribute here, username, and we just want to add password, that too in encrypted format, right? So first let's encrypt our username and password. So if you'll go to the app deployment.yml file, root is our username and root is our password. You can give any name. So for now, as per our existing code, we are using the same as a username and password. So first let me encrypt this. So in Kubernetes there is a way you can encrypt it. You just need to fire command echo -n, then give what you want to encrypt. I just want to encrypt to the root in the format of base 64. Okay, just enter it. This is what the encrypted text of my username root. Just copy this, go to your secret.yml file, paste it. Similarly, my password is also root, so I can add it here also. Okay, so let me format it properly. Fine. Now let's remove the hard-coded value from our application. So first go to the db deployment.yml file. So here if you observe, MySQL root password we specified as a value directly root here. Okay, so you just need to fetch it from the secret rather than hard code it here. So what I'll do, I will just specify value from, then where you want to fetch it, I'll just fetch it from the secret. Okay, so for that what I can do, I will just write here something like secret key reference. Okay, and give the name of your secret. So just add the name here and just add the key of that name. Okay, I will just tell you, let me add the key here. Fine. So you are telling to the Kubernetes, I just want to fetch this MySQL root password value from secret key and give the name of your secret. If you go to the secret, this is what my name of secret. Okay, just copy this, then go to your db deployment, give this name similar way. And what is the key you want to fetch from that secret? Go to the secret, we just want to fetch that key as a password. Okay, so just add it here, simple. Next let's change for this MySQL database. So first let me copy this string, then we'll just add it here. I'll just add it here. Now this particular MySQL database name will get from the config map. If you will go to the configmap.yml file, database name we specified here. Okay, in this config map. So in this db deployment, rather than pointing it to the secret key reference, so this should be capital I guess. Here also let me modify. Fine. Rather than pointing to the secret, we'll get it from the config map. So I can directly change here config map. Okay, then name of your config map, which is db-config. I'll just type it, and the key which I want to fetch is database name, because this is what my MySQL database name. So if you'll go to the config map, this is what the config name we configured, and I just want to fetch the database name. Now similarly, go to your app deployment.yml file. Here again you need to fetch from the corresponding config map and secret. So first two will fetch from the config map, second two will fetch from the secret. So I'll just copy the syntax here which we write just now. So first two will fetch from the config map. Let me copy this. Go to the app deployment.yml file. Instead of value, just replace it. Uh, this host, what key I configured here? Let me check here. Yeah, this is only host. So I'll just copy this key and I will go to the app deployment.yml file. This is the key, and then just copy the same in db name. I'll just paste it, and this is what the key. Let me copy the key. I'll go to the config map. Yeah, this is what the key. Fine, just paste it. Now I believe this is clear for you. So this db host and database name I fetched from the config map, and this is what the host key I configured in config map, and this is what the database name I configured in the config map. So let me format it properly. Yeah. Now similar way, this username and password will fetch from the secret. Okay. So I'll just copy the syntax. We just write it here, so I can directly use this. Go to the app deployment YML file. Instead of hardcode the username here, just change it here and give the key as a username. That's what you want to fetch from your mysql-secret.yml file. Similarly, change the value here, which is nothing, password. That's correct. Fine. So now we didn't hardcode any username, password, or anything sensitive information in our application. Now all the information will fetch dynamically at runtime from this secret and this config map. Okay. Now let me cross verify once. This is what correct. In here we hardcoded the name. No, that's correct. Fine. So we are good. Now let me start my minikube. Minikube start. So first we need to dockerize our Spring Boot application. Then you just need to execute the config map. Then you just need to execute the secrets. Then DB deployment and app deployment. Okay, this is what the order. So I believe everyone watched my previous tutorial about Spring Boot CRUD deployment to the Kubernetes. If not, I would strongly suggest you to check out that tutorial first, then come to this particular tutorial. Okay. Otherwise, you won't get anything. What is config map and secret? How I configured all those key value? You won't get anything. Okay. So let me check if minikube started. It will take few seconds. Yeah. So minikube started here. Now we just need to sync our minikube to our local Docker repository. Okay. For that there is a command eval, then just specify minikube environment. So I will just specify minikube point to the Docker environment. That's it. Okay. Now I will verify Docker images. There is no Spring Boot image, no MySQL image. Okay. We'll run one by one to get all the image. So first I need to build my Spring Boot application, or first I need to dockerize my Spring Boot application. So I'll go to the corresponding directory, desktop, then what is that, JavaTechie code base, then Spring Boot CRUD K8 as example. Let me cross verify once. Correct. This is what the path. Now just enter it. Just check the ls. We have this config map, secret, docker, file, app deployment, db deployment, everything. Okay. So first I need to build the docker image of my particular application. So I'll just fire a command docker build -t. Then I'll give the image name and the tag is 1.0 in the root directory. Just enter it. It will just execute all the 4 steps which we mentioned in our docker file, and it will create a docker image. So it may take few seconds. Let's wait it to complete. Yeah, So if you observe, it created the Docker image. Now if you'll check Docker images, you can see Spring Boot CRUD K8s and the tag which we added 1.0. Now as I already explained, if you'll see here all the file we have and we are in the current directory. So first step, you need to apply this, or you need to create this config map. We already created the YML file. We just need to execute a command. Okay. So I will just type a command kubectl apply, give the file name which is mysql mysql hyphen configmap.yml file. Okay. First we need to deploy this config map object. So you can see here config map db config created. Now I will check here kubectl get config map. You can see here it created the config map. Now similar way, let me deploy the secrets. So I will just add enter here. Otherwise I will just clear it. I'll just check the file name kubectl apply hyphen f and give the mysql secrets.yml file. So it created the secrets. Okay. To verify that, you can type kubectl get secrets. You can see here it created your MySQL secrets. Fine. Now we are good. We created the config map and secrets. Now since my app-deployment.yml and db-deployment.yml point to this config map and secret, so we just created the first step. Now let's deploy the db-deployment.yml file. So I can do the same way kubectl apply -f. Then I'll just give db-deployment.yml file. Okay, there is something going wrong. Deployment error validation data unknown config map key ref. Okay, so the syntax is not correct properly. Let's go to the uh, db-deployment.yml file. We'll check what mistake we did. Yeah, so if you observe here, we just added double I. Okay, so this should be config map. Then copy the same, and also we copied app deployment.yml file, the same context. Let me change it here also. Fine. Now what we can do, let's redeploy our particular db-deployment.yml file. Let me clear this. I'll just deploy the same. Yeah, so you can see here deployment.app mysql created, service mysql created. Okay. Now if you'll check here the deployment log, so I can show you kubectl get deployments mysql ready 0 by 1. It means it's starting the pods. Let me check kubectl get pods. You can see here status is running here. Okay, and if you will go and check the log of mysql, you can do that kubectl logs. You can give the name of your pod to check the log. You can see here it connected to the MySQL. So to verify that, what we can do, I'll just open a new terminal. Let me zoom this. Otherwise I can directly try from here. Cell new tab. Here I will just first let me copy the pod name. I'll directly get it here. kubectl get pods. I just want to connect to the MySQL instance which is running on my Kubernetes cluster. So what I can do, I will just fire a command kubectl execute hyphen integrated terminal, then your pod name slash bin slash bus. Okay, now you just need to log into your MySQL. So I'll just type MySQL and the name of host is MySQL. Sorry, this should be MySQL, and then specify the username which is root, and then specify the password which is again root. Okay, you are connected to your MySQL. Now just verify the database, all the databases. Okay, MySQL databases. Okay, I guess it's database only. Let me check. Database, correct. Okay, You have an error in your SQL syntax. Check the manual that corresponds my okay. Yeah, I did a mistake. This should be show databases, not MySQL databases. Okay, you can see here JavaTechie, which is the database name we created. We can see here. Okay, if you remember in the config map, we created the name of our database. It means my db-deployment successfully fetched the database name from config map and it is able to create it. So I'll just use this database. Use JavaTechie, correct. Okay. Now the next step, we deployed the config map, we deployed the secrets, we deployed the db-deployment.yml file. Now the next, we need to deploy our app-deployment.yml file, where we just provided the deployment object. We are telling to the Kubernetes, read this particular Docker image and run it inside a Kubernetes pods. Okay. Similarly, we also created the service as a node pod. We are telling to the Kubernetes to expose my application outside to the Kubernetes cluster. Okay. So already I explained about this deployment and service object of Kubernetes with my two previous example. Just have a look once. Now the next step, we just need to execute this app-deployment.yml file. So I'll just go to the another terminal, this one. I'll just zoom this. Let me clear everything. I'll just execute kubectl apply -f. Then I'll just give app deployment.yml file. Just execute it. You can see here Spring Boot CRUD deployment created, Spring Boot CRUD service also created. If you'll check kubectl get deployment, you can see Spring Boot CRUD deployment created with 3 replica. Okay, and there is another replica for MySQL. Similarly, you can check the service kubectl get sbc. You can see here one service for MySQL, one service for our Spring Boot application. Now what you can check, I'll just check the number of pods. Okay, kubectl get pods. You can see here 3 pods for my Spring Boot application, 1 pod for MySQL. Now let's verify whether my Spring Boot application is running successfully. Check the any pod name, then check the log of it. kubectl logs, give the pod name. You can see here, okay, it started on port 8080. Now also I'll just cross verify whether it created the database or not. I'll simply just type kubectl logs. I'll check in another pod. Okay, yeah, so you can see here it just created the table, order tables. You can see here. Okay, so it means my application successfully connected to the database which is running on Kubernetes pods. Now what we can do, since we exposed our application as a node port service type, if you will go to the code, you can see here, yeah, as a node port, we can able to access this particular application with the help of node IP and port. Okay, so for that, where we will get those information, I will just show you here. Clear, just type kubectl get sbc. From the service, if you observe, this is what my Spring Boot application, and the port which is node port, this is what the node port 30841. Okay, and the IP, either you can get the IP from the node, or I can directly use the minikube IP. Both are same. Okay, so I'll just copy this, and this is what the port. So I'll just try out this particular endpoint. So let me go to the Spring Boot application controller to check what are the endpoint we have exposed. Just go to the controller, just orders, post and get. Okay, that's correct. Now let me check the attribute, ID, name, quantity, price. That's correct. Now let me go to the postman. Let's open it. Yeah, so you can see here in postman last time you tried. So we'll just change the this particular host and port. Okay, host is nothing. This is what my, okay, let me zoom this. This is what my host. Okay, and port is 30841. Let's go to the postman and change it. This is 30841. and go to the body. We are just adding one order object. Just send it. Yeah, you can see here record got inserted and ID is auto generated, so we are getting one. So I'll give some random name, let's say books, quantity 5, it's 5000, not 55. Okay, send it. Two object we added. I'll just add something called glass 2 999. I'll just add another product. You can see here IDs keep increasing. Okay, and I'll give something called mobile, quantity 5, not 5, 2, and price is 1 lakh. Okay, just send it. You can see here we just added 4 objects. Now I can directly do the get call to this particular endpoint to view all the product whether it is there in my database or not. Just send it. You can see, let me zoom this, all the 4 order object which we added. You can verify same in the browser as well. I will go to the browser. I will fire this particular endpoint. You can see here all the 5 object which we added. Now let's verify same in our database. So let's go here. I'll just use so tables. You can see here order tables is there. Now I'll just fire query, select star from table name. Okay, so this is the table name. So let me execute this. You can see here 4 record got added to the database which is running on Kubernetes. Fine. So in this particular tutorial we just understand how to segregate sensitive information of your application to the outside to the pods. Okay, so that's the reason we just use two component, ConfigMap and Secrets. In Secrets we added the information in encrypted format, and in ConfigMap we added the information in plain text. And in both the DB deployment and app deployment, rather than hardcode those details or sensitive information here, we either point to the secrets or we point to the config map based on our required inputs. Okay, you'll find same in the app deployment.yml file. I hope this context is clear for you. Now what we'll do, we'll just verify the minikube dashboard to check the health of our components. So for that I just need to enable the dashboard. So just go to the this one. I'll just add enter. We'll just type minikube dashboard. It will give us a, it will just redirect us to the dashboard URL. Yeah, it redirect us. We can verify all the components. So this is what the deployment 2 object, and pods are 4, 3 replica for Spring Boot, 1 for our MySQL. You can see here these are the deployment and these are the pods. And if you click on the config map, yeah, you can see here these are the config map we created, db config, and you can see the value. You can also modify the value here. Okay, and similarly I believe, yeah, secrets is there. You can check the secrets. Fine, MySQL secrets, that data is encrypted so it's not showing here. Let me see if, yeah, it's in format. Fine. So if someone have access to your Kubernetes dashboard, they can visualize, but usually we need to configure the namespace, so and those information we cannot see directly in the Kubernetes dashboard. Okay, so I just want to show you the config map and secrets component we just covered. Even we just covered the persistence volume claim because we added the MySQL PV claim in our db-deployment.yml file. Fine, and we have the pods, we have the deployments, maximum components we almost covered. That's what I'm just trying to show in this particular dashboard. Yeah, so this is how you can use the config map and secrets in your application.
That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.